gonna skip 5-1 and come back to it.
Yeah, were we supposed to?
Were you supposed to do that?
Were we supposed to do that?
No, it's fine. If you did the notes for 5-1, like that's fine. We'll get to it. I'm just changing the order a little bit.
True that.
Yeah, I don't think too many people were doing notes over break. What the? I'm shook.
I was shook.
Shaken.
When did he leave?
That's so
What day? I think it was
That's just great.
last week. Not 2
It's
weeks.
okay.
Real down.
Like pretty quickly after. When did the coach get fired?
So we
Not even
last day of break. I think we had Friday off, right?
Yeah.
We played Ipsy. We beat Ipsy.
On Friday?
On Friday. Coach got fired Saturday. Yeah. It was the next day. And then Trey left like
Sunday.
Wait, how did he leave so quickly? That's so
That was like
weird.
Christmas was like Sunday, so then like
he left. No, from what he made it sound like his parents just sent him down there. His parents just said,
What?
I don't know. How much money do these people have? So probably much more than I do.
So many. We should question it. Yeah,
we'll be here soon.
Will tells the tea. We're like,
Spill the tea.
spill the tea. Will just has all the
He does. He is after all on mission.
I'm still like recovering.
No, that's literally on the package.
Yeah,
Who drew that?
Yeah, I don't think I can. I don't think I can.
So bad.
I'm too sad to
It's
just
so
like.
weird.
Sorry.
Well, like this sounds like the answer makes so much sense. That's just like
Okay.
I thought you were.
So where we're like starting to head is, I think I've told you guys this before. Like I'll give you some equation, like say it's 2x over x minus 1, and you'll have to graph the entire thing without your calculator. So you'll be able to identify horizontal and vertical asymptotes, which we've done, but we'll review. Where it's increasing, where it's decreasing, where it concave up, where it's concave down, where there's maxes and mins, points of inflection, all these things. So that's probably what your next quiz will be. I'll just give you, like, what I've done in the past, I think, is I'll give you 4 equations and say I'll grade the best 3. So if you can finish 4 in class, then you could screw one up and I would still do your best 3. Or if you can only finish 3 in class, I'll grade those 3. But it'll be a 3 or 4 question quiz where it's just like, here's an equation, like that could be one question right there. Then you got to do a buttload of stuff with it, but we'll like go through all that as we build up to it. Okay, so I'm going to use these terms, but these are the same. So global and absolute are the same thing. Local and relative are the same. So you should be able to look at a graph and tell me the absolute max and the absolute min, and then the relative max or any relative maxes and relative min. So the absolute is like the overall biggest and smallest. Well, we're on 5-2. We did 5-1 before you got here. I hope you can catch up. No, we're skipping 5-1 and coming back to it. So absolute is the overall biggest and smallest on the whole graph. And the relative is like bigger or smaller in its area. So that'll probably make some more sense after I do a couple. So if I'm looking at the graph, I'm going to start with like the absolute max and the absolute min. So I'm looking at where is the highest y value on this entire graph. That's this. So that's the absolute max. Then the lowest y value on the entire graph is the absolute min. And then you're going to check like peaks and valleys and kind of any circles too, to see if there's a relative or a local max or min. Let me start with this one. So like right there. If I just look at like the area right around it, that's lower than the points on either side, right? But it's not the lowest point on the entire graph. So that's called a relative min. Or you can call it a local. this point right here, I look just kind of like on either side of it a little bit. Is that the lowest point in its little neighborhood there? That one is. So this is also a relative min. 500 things on my graph. So that's a relative min. That's a relative min. This is the absolute max because it's the biggest on the whole graph, and that's an absolute min. That open circle is not like bigger than everything around it or smaller than everything around it. Does that make sense? It's not like the top of a hill or the bottom of a hill. This one is where people start to get a little tripped up. So let's say that that has a value. Let's say that that's 3. What's the biggest y value in this little neighborhood? So, but if you like, keep going. What do you think it is?
2.99999. Well, it just gets like really.
Yeah. So at some point, if he gets exhausted and stops saying 9s, I could be like, well, no, it's 2.99999, and I can say like one more 9, and then he's gonna be like, okay, fine, dick. I'll just throw another 9 in there, and like we could just keep going forever, right? So is there a y value here that is the biggest one in its local area, or does it just like keep getting bigger and closer to 3? It just keeps getting bigger and closer to 3. So you can't say the biggest y value here is 2.999999999, because then I could just put another 9 there. You can put another 9 there, and we can just keep going back and forth. So this is not a relative max or an absolute max or anything. So open circles are goofy because you don't ever get to that value. You just get really close to it. So this is nothing. This, though, if I look at the little neighborhood, is that bigger or smaller than every point around it? It's smaller than everything in its little area, right? Because everything else is up there, and this one drops down here. So that is a relative min. And then endpoints are weird. This blows my mind that this happens in like a discipline like math where everything has rules. Some people will tell you that is a relative. Well, what would that be? A relative max or a relative min? Your relative max, it's like taller than everything around it. And literally, some calculus books will tell you it's a relative max, and some calculus books will tell you endpoints cannot be relative maxes. So for your purposes, you'll never be asked that on my quiz or test. You'll never be asked that on the AP test. It's just kind of like, we don't agree on. Imagine arguing about that. Imagine like getting all fired up about that. It's just like we don't agree on it, so we're just gonna like pretend it doesn't exist. We will not ask that question.
So they can be absolutes, though, right?
They can be absolutes for sure. Like this one here is an absolute because I can say like that is big, lower than everything around it. The idea with a relative is you're supposed to be able to say it's lower than everything around it, meaning on both sides. And since the function doesn't exist over here, it's like, is it or isn't it? I don't know. I don't care that much. Some people do. I just like move on. Yeah.
If that were to be higher than like absolute max, would the endpoint be?
You're doing a hypothetical.
I know.
If this were way up here,
Yeah, but this isn't like a crazy thing.
that would be an absolute max.
Okay,
Yeah.
so it can be.
It can be absolute. Relative, you just won't be asked about. So let's look at like number 1 and 2 here. So, why don't I do 1? We'll kind of talk through it together, and then I'll have you guys do 2. I always start with like the biggest, the absolutes. So where's the biggest and where's the smallest? So this is your absolute min. And I should probably write it out. I think I keep this in the video too. So the absolute min is 1, occurs at x equals negative 3. So the min is the y value, and then it occurs at is like, okay, where's that happen? That's the x value that goes with it. what is the absolute max? 5. That's the highest y value on the graph, right? And where does that occur? At x equals 0. So the absolute max is 5. Occurs at x equals 0. And then we're going to check for any relative mins or relative maxes. So I'm going to look at like open circles because they might be something. Well, let's just look at like this. Like something happens there, right? I don't know what yet, but like something definitely happens there. Is there a point in this little neighborhood that is smaller than everything around it? Is there a y value there that's smaller than everything else in that little area? There is, right? Isn't that y value smaller than these y values and then those y values? So that's a relative min because it's the smallest in its. It's like you're small in your neighborhood. This one's the smallest in the city. Or like you're small in Milan High School, but this is the smallest in the state, or something like that. So that is a relative min. Is 2 occurs at x equals 1. And then that endpoint is an endpoint, so we're not going to worry about it. If this was closed, what would that be? If it was closed and not an endpoint, what would that be? That'd be a relative max, right? Because it would be like taller than the things around. Try 2. See how that goes. There does not have to be an absolute max or absolute min. Sometimes there's not. I feel like Trey would answer the question right now. That would be like good. Does he know what I was?
I don't think I was fired right away. Because, like, if things don't change by the end of the season, we might make some changes to that deal. And then I went to the conversation didn't go very well. And next thing you know,
Gotcha. Who's coaching now?
Coach Morgan, he was Coach Pope's assistant. And he just started with the program. All the other coaching deals, so he just moved up and
See what happens after this season. Bryce will do it.
What'd you ask?
I think Bryce might do it. Because then Steve.
Oh, Steven?
I would hope so, but they would be good to the dirty.
He's been coaching in the program since I was coaching. Which
Yeah, I thought that they
Long
had
time
to hire the teachers first. Teachers had like
is
first.
supposed to, if they're like qualified, which he is. Yeah. They couldn't, like, I couldn't just go be like, I want to coach the equestrian team. I'm not qualified to do that, so. But if you have, like, which he definitely does. Alright, anyways. So, is there an absolute max in this graph? So the absolute max is that point. So the absolute max is 3. Occurs at x equals -1. Is there an absolute min? There's not. So it kind of looks like there is because the circle is like at the bottom of everything, but I don't have a lowest value because the y values are just going to be -2.9, then -2.999, and negative. No matter what you say, I can say one. So there's a rule in math: no matter how close two numbers are, there's always one in between them. So no matter how close I get to -3, I can find a number in between whatever you just told me at -3, and we can just keep like getting lower and lower. So there's not going to be like that one. If that was a solid point, that's your absolute min. But if it's open circle, it's not. Yeah.
I could
I guess then the argument would be like, well, I could repeat more. I don't know. That's a valid question, but like, so again, go back to like what I just said. No matter what two numbers there are, I can find one in between them. I feel like you're getting like too technical about it, worrying too much
Yeah,
about
no,
it. Yeah, no, I don't have a great answer.
Yeah.
Is that fair? Okay. This guy here, what is that? That's a relative max because it's taller than everything around it, and that is an endpoint. But let's say it wasn't. Let's say it did that. What would that be? Relative min. Let's say I give you this graph. What's the absolute max? There's not one. What would the absolute min be? There's not one of those either. Because no matter what number you say, I could say one smaller. So then you could say, like, well, isn't it negative infinity? Kind of the same idea as your 2.999. And technically it's not, like, wrong, but we would just say it doesn't exist. Because I could say one smaller. I don't want to spend too much time on this. It's not that big of a deal. Just getting the idea of like an absolute max and min compared to like a local max and min. So let me give you like a more kind of straightforward one. What's that? Relative max, relative min, absolute max, absolute min, relative max. So that's like if you can do that, we're good. Not really sure what this is. What's that? Absolute max, relative min, relative max, relative min, relative max. Is there an absolute min? Technically no, because it goes down forever. Oh, I think I know why it's there. So notice in your derivative, what's the slope at that spot, that spot, that spot, and that spot? Zero. Remember, the derivative is the slope, right? So critical points happen in two spots. Either when the slope is zero, or the derivative is zero. Or, what's true about the derivative right here? It doesn't exist. So those are the two things you're looking for. I think I remember seeing that in the notes on the next page. Yeah, so how do you find a critical point? I might phrase this differently than him, but you want to know when the derivative equals zero, or when the derivative does not exist. But typically what you're doing is you set the top and bottom of derivative equal to zero. So those are what's called critical points. That means something important happens at that point. Critical. So this is kind of where we start doing, like eventually on your quiz, I'll give you this and say, you got to graph. So you're going to tell me all the information about it. Asymptotes, critical points, increasing, decreasing, concave up, concave down, points of inflection. I think that's it. So we're just kind of building that. So finding critical points is just where does something important happen. So you're going to take the derivative. So you guys remember how to do derivatives. So 3 times 1/3, bring that down, that's x squared. Negative 9x, negative 9, and the 24 is 0. And you would set the top and bottom of this equal to 0. If there's not a bottom, you obviously can't set the bottom equal to 0. But something like in this one, there will be. But you're going to set the top and bottom equal to 0. Because if the top equals 0, that means your derivative equals 0. If your bottom equals 0, that means your derivative doesn't exist. So this is covered at both bases. So if I just solve that, I will get x equals plus or minus 3. And then when you go to do your graph, and it's a good idea to do it now. I don't think they put it in the answers, but I'll show you in number 4 why I think this is a good idea. You're going to want the point on the graph. So I don't really care that much if you go through and do like 1/3 times 3 to the third, like if you calculate it. But the idea is, can I calculate it? If I plugged 3 in here, would I get a number? Yes. If I plugged negative 3 in here, would I get a number? Yes. What I'm getting at is let's say I worked this one out and I got 2 for my critical points. If I plugged 2 in here, would I get a number? I wouldn't. So it's not actually a critical point then, because it's not a point on the graph. But these two I would get a number, so this is an actual point that would go on your graph. And I can do it. So like this would be 9 minus 27, so negative 18 plus 24 is 6. This would be negative 9 plus 27. It's not 42. That might do it. Here's the notes. Negative 9. What? 42. We good? Okay.
Zach's out.
So this graph, I believe, goes something like that. Now, this is not to scale, but your negative 342 would be like here. And then 3, definitely not to scale, but those are like the peak and valley of your x to the 1/3. We'll start to build that. But for right now, it's just find the critical points. And really for today, they're just asking for this. I'm just saying in your head, it's probably beneficial to start thinking about, I'm going to want those y values eventually. Or at least, could I find those y values if I plug them back in? So if I do number 4 here, I would rewrite this first and say this is 4 minus x squared to the negative 1/2. Remember, because the square root's the 1/2 power. That's on the bottom, so I'm going to bring it up. And this allows me to use chain rule, which I think is a lot easier than quotient rule. Take my derivative. So bring down the negative 1/2. Leave the little guy alone. Reduce the power by 1, and then multiply by the derivative of the inside. And now you got some simplifying to do, because you need to set the top and bottom of the fraction equal to 0. We don't have a fraction right now. We have to make one. So the negative 1/2 kind of sets me up and gives me a top and a bottom. The 4 minus x squared to the negative 3/2, I'm going to move that to the bottom so that the exponent is positive. And then the negative 2x goes on top, and we don't have very much room here. So, like, what I really have there is, let's say, 2x over, and I could cross those 2's out, I know, but let's just say I have this. Your job is to set the top and the bottom of that fraction equal to 0. So set 2x equal to 0 and solve it. You get x equals 0. I don't need to know what it is, but could I plug 0 back into that and get a y value that goes with it? If I plug 0 in here, it'd be like 1 over the square root of 4. That's a number, that's totally fine, so that is a critical point. Then I'm going to set this guy equal to 0. And these are kind of nicer than they look, because basically you just end up doing this. So let's say I divide both sides by 2. Well, what's 0 divided by 2? 0. So that 2 is basically meaningless. Then, let's say I raise both sides to the 2/3 power. What'll happen to those 2 powers? Cancel. And what's 0 to any power? 0. So you basically just end up with 4 minus x squared equals 0. So it looks like it's like way more difficult than that. But everything cancels because you're working with a 0. And then this will be like x squared equals 4, which will give me x equals positive or negative 2. So again, I don't have to do it, but think about it. If I plugged a positive 2 back in there, would I get a number? What number? I get 1 over 0 though, right? So 1 over 0 is not a number. So it's not a critical point. If I plug negative 2 in, same thing. I get 1 over 0. That's not a number. I can't graph that, so it's not a critical point. So those are important for other reasons, but they're not critical points because they're not points on the graph. Make sense what I'm doing? Questions? For that one, there's only one critical point. This. And these will, like, we'll use this for other stuff. What are those? You guys remember? There's something. We've talked about it. 0 on the bottom and something else on top. Vertical asymptote.
I got the asymptote.
So those are vertical asymptotes, yeah.
Alright, 4 and a half.
Okay. Where's the horizontal asymptote on that one? Let's start reviewing a little bit. Where's the horizontal asymptote here? Think about the higher power. It's on the bottom. What's that mean?
That means it's 0.
I mean, when you say it, I get confused. What's it?
Straight line is
The straight it line is 0.
right? Something divided by a really big number is 0.
It is. So where's my horizontal asymptote?
That's 0. That y equals 0.
That y equals. So like right now, just kind of thinking ahead, I've got a horizontal asymptote there. I've got a vertical asymptote at 2. I've got a vertical asymptote at -2. And I've got a critical point at 0, comma 1/2. So like I've started to build that graph, you know. And we're gonna put shapes in around it, but that's like, you know, just pointing down the road a little bit. Questions on what I'm doing up here? You guys good to go, or you want me to do more examples? Don't worry about the trig one. So don't worry about 8. You can, you know, if you're looking for a 5 in the AP test, do it, check it out. I'm happy to help you with it, but I'm not worried about it here, and then do the rest. We'll